In this lesson, we're going to review central and inscribed angles in the circle. Here we have a circle with a center O. If we were to draw a radius from the center to the edge of the circle, we could note that if we were to go all the way around inside the circle, it would be 360 degrees. So based on the fact that we could go 360 inside the circle, to 360 degrees in a circle, we could relate that to the circumference. So the entire circumference, we'll say, would be 360 degrees, and any portion of the circumference would be some fraction of the 360 degrees. The fraction of the circumference is related to the central angle. So if we were to draw another radius here, for example, and the measure of this angle that's formed here, we could say looks to be about 40 degrees. Well, if this angle formed here is 40 degrees, then this arc is also 40 degrees. So this 40 degrees represents 1/9 of the entire 360. This length here, this arc, is 1/9 of the total circumference. So the central angle, it's a central angle because the vertex of the angle is at the center. Whatever the measure of that angle is equals the measure of the arc it intercepts in degrees. Let's look at inscribed angles now. Inscribed angles have their vertex on the circle. So this type of angle is an inscribed angle. And again, let's say that the measure of this arc is 40 degrees. Then the measure of this inscribed angle is directly related to that. Inscribed angles are half of the arc it intercepts. So if we could look at how central angles and inscribed are related, let's draw our central angle again. The measure of this angle was 40 degrees, which is the same as the measure of the arc it intercepts. The measure of the inscribed angle here is 20 degrees, and that's half of the measure of the arc that it intercepts. So just focus on the inscribed angle. This measurement, the 20 degrees, is half of this length of the arc in degrees, as long as it's inscribed and it intercepts this arc. So for example, we could have the angle in a different location. This angle is inscribed because the vertex is on the circle, and it intercepts this arc, so that this would also be 20 degrees. And if we drew it over here, the measure of this angle would also be 20 degrees because it intercepts this 40 degree arc. What I mean by intercepts is, if we were to continue this line of the angle, we would have this arc that's in between it. That's the 40 degrees we're talking about. So same thing with the right angle. If this were to continue, you see that this arc is in between. It's the same exact arc. And if we continue with our original angle, again you would see that this arc is in between it. That's the intercepted arc. So whatever the measure of the arc is, the inscribed angle is half. So I'll add the central angle back to the diagram. And the measure of the central angle is the same measure of the intercepted arc. So this is 40 degrees. So you can see that if a central angle and an inscribed angle intersect the same arc, the central angle would be double the inscribed angles. And likewise, the inscribed angles would equal half of the central angle.